Yo, what up, Sci fam? It's your boy Nickel here, and today we're going to look at some of the attributes of Earth as it orbits around our star, the Sun. So, we're going to be looking at some of the orbital characteristics, its speed, tilt, and distance from the Sun, as well as some of the things that actually cause Earth to have some unique climate changes over the course of its history, its 4.6 billion year old history. So let's dig in here. Now, Earth is the third rock or the third planet from the Sun, our star. And the average speed it travels as it orbits that star, the average speed of the orbit, is about 66,600 miles per hour. That's zooming around that sun. Now, the sun's gravitational pull is what keeps the Earth orbiting in orbit around the sun, even though it is traveling that fast. Now, the tilt of Earth's north-south axis, which basically is, if we were to look at the tilt of the Earth, and if we were to draw a line going right from the North Pole down to the South Pole, there's actually a tilt to our Earth. And that tilt, if we were to measure it, to figure out how many degrees of tilt there is, the tilt that our Earth has is 23.4 degrees. And that'll come into play here shortly as we look at how that tilt can actually change over time. Another thing that changes over time is the distance of our Earth from the sun. And we'll talk about how long it takes for that to happen. So if you see here, our Earth orbits the sun. It's obviously the third planet, so this is not to scale or even representative of our solar system. But if we see the Earth, and we were to see its orbit would be in this kind of squished circle. We call that an ellipse. So the distance that our Earth is from the sun actually changes. You see, this ellipse is not directly equal distant from the sun. So if we were to measure the distance that the Earth is from the sun in one point of the ellipse, it would be shorter than it is on another part of the ellipse. So the part that is here on the right side, the part that is a larger distance away from the sun, is called the aphelion. And on the other side, the shorter part the shorter distance from the sun to the Earth in its orbit is called the perihelion. Okay, so let's actually record the distance in our current Earth's orbit around the sun, what the distance is at the furthest distance and the closest distance. So you can get some type of scale as to what this elliptical orbit would look like. So first, let's record the perihelion. The perihelion distance, that shortest distance, the closest we get to the sun, would be 91,400,000 miles. And if we then compared it to the aphelion, or the furthest distance that the Earth gets from the sun, this would be 94,500,000 miles. So you can see there's about a 3,000 and some change million miles from the furthest distance to the closest distance the Earth is away from the sun. All right. So as I kind of previewed earlier, the tilt of the Earth can change over long periods of time, and so can the distance of the Earth change over long periods of time. And since these things can change, imagine if the Earth were much, 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 much closer or much, much, much further away from the sun. That would affect the temperatures that we have here on Earth, because it would affect the amount of solar energy that reach the Earth. Also, if the tilt changes, imagine if you look directly at the sun versus if you look at an angle and allow the sun to be on the side of your face. The amount of solar energy that you can feel on your face is different, whether you're directly looking at it or if you're looking at an angle. So if we tilt the Earth, it's going to also absorb the sun's energy at different points here on our Earth. So these different changes that can happen to the Earth that affect the climate are called Melanchovinch cycles. Melanchovinch cycles. Now on my page, I'm going to draw a box around this to really bring the focus to this word here so that I remember if I'm looking for the Melanchovinch cycles, hopefully that will draw my eye to this portion of the science notebook page if you need to come back to reference what the heck the Melanchovinch cycles are. Now, like I said, the Melanchovinch cycles are changes to Earth's movements, like how far it is, its tilt, and so on, over thousands of years. Really tens of thousands of years. So it's changes to Earth's movements over thousands of years that end up affecting Earth's climates. So it's not the climates that are just changing on their own, but it's because of the movement of the Earth that is affecting then our climate. So the first thing that can affect the Earth's climate is something that we call eccentricity. And eccentricity is the shape of the orbital path. And it fluctuates between elliptical and more of a circular type of orbit, actually. So the eccentricity, or if we look at how the Earth here is orbiting around the sun, as it orbits, it actually has an orbit that goes from elliptical, more of that squish circle, to more of a circular orbit, where the perihelion and aphelion are more similar in the circular orbit, whereas they're more different from each other in the elliptical orbit. So the eccentricity is just the shape of the orbital path, and it fluctuates between being elliptical and circular. So it's going to be, if we look at the orbit around the sun, let's get the dashed line out here, it's going to be either more of a elliptical path, or it's going to be more of a circular orbit around the sun. And like I was saying, this takes a long time. It's every tens of thousands of years, or even longer than that. And specifically, the eccentricity is on 100,000 year cycle, about every 100,000 years. We go from more elliptical to more of a circular pattern. And it doesn't just change overnight, it's a slow shift that happens to the elliptical orbit. As the Earth orbits around, we can imagine that as it gets close to the sun, it gets shot further. When it comes back, it could then have a different path, and then it gets shot out, and so on. So that change in our orbit, it's very subtle, but it's more elliptical and more circular, and that happens every 100,000 years. It takes 100,000 years for that to fully fluctuate from one phase to the other. The second Melanchovinch cycle is something that's called obliquity. Ooh, that's a weird word. Obliquity. I hadn't practiced saying that one out loud. You might need to practice that one yourself. Say it with me. Obliquity. Or we can just say the tilt. Much more simple there. So we'll just write tilt. The obliquity of our Earth is also known as the tilt of the Earth. So Earth's tilt actually fluctuates between two different degrees. It goes from anywhere from 22.1 degrees to wobbling more close to 24.5 degrees. Now, as we saw above, right now the Earth, currently, it's at 23.4 degrees. So that means that if it fluctuates between these two different tilts, we're currently like in the middle of the two. So what that means then is if I were to take a dashed line and draw it from the north to the south, both of these Earths here are at a directly 0 degree tilt. There is no tilt. But if I were to take my tool here and tilt this Earth, let's say that this one's going to be the 22. Whoop, we ended up getting a bit smaller there. Not on purpose. And this one can be the 24 degree. So you can see this is extremely exaggerated. But this could be like less tilt, meaning 22.1 degrees to 24.5 degrees is a maximum tilt. And it kind of wobbles back and forth between those two. And this takes not as long as the eccentricity or the changing of our orbit. This happens typically on about a 41,000 year cycle. So every 41,000 years, we go from 22.1 to slowly increasing to 24.5, and then we come back towards the 22.1, and that happens every 41,000 years. All right, the last of the Melanchovinch cycles is something known as precession. And precession is another fancy word, and we can summarize it with the wobble of the earth. Anyway, precession is the wobble, and it's basically Earth's wobble as it spins, because it's orbiting, it's spinning in space like a top does. Now, maybe you don't know what I mean by a top. Okay, here's a little top right here. This is like a kid's toy. And when you spin this thing, even though it's staying upright, you can see there's that little bit of wobble there. That is known as precession. Okay, so even this top has precession. And so if I were to draw it here on my Earth, here's my Earth with the dashed line, it just means that like pole, the pole of our Earth, kind of goes in this circular type of direction as we're spinning. And this also takes a really long time. This takes 26,000 years for it to go all the way through this kind of wobble path. And you can imagine, if we don't have as much tilt on the Earth, then that wobble is going to be smaller than if there's more tilt, then it's going to have more of that precession. But it typically takes for it to go around one of those cycles about 26,000 years. Now let me show you more specifically. Here's the Earth here, and you can see that instead of just looking at the stars up here, let's actually look, let's crop that real quick to get rid of that and just show that if we have the Earth and we take a look at its motion, that as it's orbiting, just like a top does, it actually wobbles like this. But again, this takes 26,000 years. Now, each of these processes of movement, whether it's the wobble of the Earth, the precession, the tilt of the Earth, or the obliquity, or the eccentricity of our Earth, meaning how the shape of our orbit changes, these things all affect the types of climates that our Earth can have, because it affects the amount of solar radiation that's actually not only hitting the Earth, but the angle at which that solar radiation is able to hit the Earth. So we'll learn more about climate and the seasons and things related to the Earth and what it actually looks like on the Earth and what causes these changes. But it's important to know that our Earth out there orbiting our sun is constantly in a little bit of motion. There's a little bit of movement, and every little bit matters. We'll learn about how it matters in our next lessons. Adios.